Hey, what's going on, guys? GoTran here. I haven't been doing some live coding here on Chess Programming channel for quite a bit of time, and in this video there would be some thankfully to Gontran Lemaire. I'm not sure if I'm pronouncing the guy's name correctly. So he mailed me a move generator, which is literally a clone of the move generator of WukongJS, but rewritten or ported to TypeScript. So TypeScript is a superset of a JavaScript chess language created by Microsoft. By the way, that's the reason why I didn't ever have a look at that, and started instantly hating TypeScript after having a look at the source code and trying to make it work. Basically, I don't really like the whatever Microsoft like, whether it's Windows, Office, or whatever products. I don't know, because from the Linux user perspective, it's a long story to describe why I don't like Windows and Microsoft in particular, Microsoft and Windows and all the products related. But this personal opinion doesn't really matter that much. So it just everything has got clear when I realized what's wrong with TypeScript for me personally. But anyway, the results of the benchmark of this mode generator ported to TypeScript is very impressive. It's much faster than my own, bearing in mind the fact that TypeScript actually maps to JavaScript directly. So it's generates the JavaScript file that you can later on run in your browser. So without further ado, let's actually go for some experimenting. So okay, let's just start with the very beginning. So I just want to close all the stuff here. So here I've just downloaded, I've git cloned the repository of this guy. Okay, and here is the project. So this is the Node.js project. I had to install the TypeScript. Well, hopefully you don't need to reproduce the steps, because I would have shared the JavaScript already, the JavaScript version of this sort of by the way, license. Does it low mid license? Well, it's a bit interesting to have a look at the license of the clone of your own source code. But anyway, so it allows you to do whatever. Well, actually, I didn't provide the explicit license to WukongJS, so yeah, it's a little bit questionable here. But let's just drop this at the moment. Doesn't matter really that much. So I don't know how to run this npm modules correctly. So what I did, I just kind of compiled, or I don't know how to call it properly. So I've generated this JavaScript file using the command line tool of a TypeScript language itself that I've installed with npm package. So eventually we have a JavaScript file. So that's the main thing to consider. So the original source code is written in TypeScript. So here is how it looks like. And it has been translated to pure JavaScript. And what is a very interesting thing, that when I look at this code, this so kind of like from the algorithm perspective, from the architecture perspective, this is literally a clone of my own code. And yeah, this is really so. But when I look at this code, even being the author of this code, I can't literally understand anything. So that's how easily one can kill the didactic, the didacticness of a chess engine while applying this so-called best practices that good for production, or I don't know where exactly. But I just try to read through this code, and it's very hard for me to understand like, what's going on here. If I wasn't the author of this code, it would be, yeah, it's too hard. Well, hats off to the author, because I don't know what he did. Probably not he, probably that's the matter of TypeScript, made all the necessary memory optimizations to make it working much faster. So that's the topic of today's research. Basically, I didn't yet do this on my own, so this would be completely live research on how the heck this is so much faster. So yeah, so I just wanted to show this TypeScript code just to give you the idea. So he uses this types for all. Well, by the way, did he just replace my type move? So it's not really that same, basically. It seems to be quite pretty different. So yeah, I see he was using bits for ranks. Maybe that also made some major speed ups. So this is very unclear to me. I probably need some much deeper research than the format of a video allows me. But again, like, this would be already a totally different engine. Well, forget that. So let's have a look at the JavaScript code that has been generated from that TypeScript source. Okay. Well, anyway, first I just want to try to, so yeah, here I'm going to create the perf test function in the way appropriate and more handy to me personally. But before that, we can just, yeah, I just want to run this one. So it's very unhandy for me the way it's going here, but it's good enough to see how impressive the results are. So you see, like, it goes instantly to depth 5, and it takes very miserable time to go for depth 4, and very miserable time to get for depth 5. While for WukongJS it takes really longer. So I don't really want to run them in this iterate and deepening mode. Instead, I just want to run them in a plain mode and see the test running in the kind of live. So for that reason, I'm gonna be just copy pasting my perf test from WukongJS, and just it's incredibly important for me to use the patterns I'm used to work with, because otherwise it's really hard to compare visually what's different there. Okay, so I just want to search for my perf test. Here it is, and just grab the entire function. Well, I guess I'm not gonna be capable of printing the coordinates, but at the very least I would be able to deal with the timing, hopefully. Or even if I can, well, I'm not sure, does it actually use the board or another name for the board array? It's interesting to see. Board. Okay, so he uses board like this. Does he use coordinates like I did? Probably not. Okay, just let's try to search for that first. Function to square coordinates. Oh. So he uses the functions. Oh my god. Oh man. To square coordinates. Oh, this is the rocket science to me. Sorry guys, it would be much faster to, I don't know why people complicating things so much when you can make it very easy way. So let me just try to grab my own pieces of code. And okay. Save. Yeah, I can hardly believe that this is gonna be working just straight ahead. But anyway, let's try. So in the email he wrote an interesting thing that yeah, I really like your didactic gradual approach. Yeah, unfortunately I'm too dumb to replicate Alpha 0 and Mu 0 papers. Sorry for that. Says follow some videos. Apart from the coding style, my mood generator would be considered as a clone of yours. But it turns out that not only the coding style actually, so probably what he calls the coding style might be result in a better performance as well. So it's a very interesting thing to research, because again, like, the result is very impressive. So okay, so notes. I'm not sure. Does he calculate what what variable he uses to calculate the nodes. Oh, so he returns the nodes from the perf. Oh man, this is not... Man, why people complicating things so much? Oh my god, this is so... Well, I believe it's just better to... So we have this make move. Okay, take back. Okay, I just try to rewrite this perf as well, because it's incredibly unhandy to work with this sort of stuff for me personally. Yeah, perf driver, and just make it global nodes. This code style is so damn good that noob like me can't really understand what's going on there, because of, I don't know, even being the author of this chess engine, believe it or not. Okay, so nodes is equal to 0. Why people complicating things? Why should you doing this? Just so weird. It's the reason that because I couldn't actually understand source code from other strong engines, and even not even strong engines, other engines, for quite a bit of time, basically. Okay, so this can be... Why do you return here? Are you kidding, man? Okay, so let's drop nodes here. I don't want return nodes here. Here I just want to calc to add the nodes. I don't want this nodes. Okay. Okay, let's start code-making trial and error method to see what we can do eventually. So yeah, it's not, I just want to take all of the code that I'm gonna be writing here. Control X. I just want to CMK code below. Okay, print this all over in here, and so initializing the board from FEN for the starting position. I don't want to make, so this was within the original code, by the way, so I don't want to make this anymore, and this was still in the original code. And what else? So let's put it below. Okay. And now I just want to run the perf driver and to see what errors I would have. Okay, call stack size exceeded. Are you kidding me, man? Generate moves. Sorry guys, I was a little bit distracted. So okay, why the heck he calls it recursive? Well, it's fine, but okay, generate moves. Okay, just how it's also different. It's very, very different. Why the heck? Oh man, that's why I hate to delve within someone else's code. Okay, generate moves. I can do a very simple stuff that I want to do, but I can't because of this good practice, best practices coding style. Okay. So he creates the move list. Oh, okay, so he creates the move list before generating the moves. I'm pushing this, and eventually he returns the move list. Well, it's quite pretty logical. What I was doing, was I doing the same? Yeah, I was just creating the move list before the generate moves, I guess. So let's have a look. Generate moves, that's more explicit way. Yeah, and it was taking the pointer to the move list. And let's go to perf driver. So yeah, I was just creating a move list, passing the pointer. Okay, so this is fine. So okay, let me just grab my own perf driver. Okay, try to make it work. So he suggests doing like this. Oh, I was just calling the wrong function there. I guess that was the disaster, right? Okay, so it seems like it works. Perfect, just perfect. Okay. Okay, and he calculates some nodes here as well. Oh, so this is my code. Yeah, just resetted the nodes to make several perfs in the row, producing the correct number of nodes. Okay, so let's make it like this. This is the only difference basically. And I'm not really sure. Okay, so this coordinates most likely would not be working now. Yeah, because I can't get this. Well, actually, I don't really care what move we currently have it, because we're not debugging anything. So I can just bring the old nodes like this and hold my breath and try to run. Okay, excuse me. Oh, perf test, I need to specify, well, let's go depth 4. Excuse me. Okay, what's... Hold on a sec. Oh, now make move. Yeah, so his make move is working oh my god, what have I done? His make move is just working different way. It's not returning anything. Oh man. Okay, let's go for his perf. So here is his condition. Let's try to grab this condition basically and try to replace it. Okay, try to replace it here. And okay, and also perf how he makes the move. So make move. Okay, okay, so yeah, and I also want to obviously to initialize the move itself. Copy. Okay, so the move has been initialized here. Making move, taken back, and also here, and make move, take back, and this condition. Oh my god, why to complicate things so much? So unhandy. Okay, hold my breath, try again. M is not defined. You're kidding me. Yeah, it's not defined because I call this count here and here. Yeah, this is so weird. So do we enter the loop of the moves? I'm just wondering. Okay, seems like we do. What else? Okay, so we don't enter here. Now this is really getting weird. Okay. Oh man. Okay. Oh, so this should be... Oh, make move goes before. Oh man. What a weird implementation. Well, probably it's much better than my own, but oh my god, I'm getting so pissed off when I see this. Okay, so should take the make move first, and not to continue here, but to run this actual perf only, like in this case here. Oh my god, will I ever be able to make this piece of code work? Control, let's take them both. Okay. I don't need this move anymore and just want to take this one here. Okay. Take number, I don't know what. Take back is not defined. Okay, this is now much better. So let's see how take back. Okay, both lower cases. No camel case. Okay. Okay. Take back. Take back here. Oh, okay, finally. Oh my god, finally. So I can't print the move yet. But forget that. That doesn't matter which move in particular here we have. So this is the speed comparison. Okay, so we can already go for comparison the speed. So just want to try the tricky position, so-called tricky position, this one. Okay, now finally I'll have a measure to compare the performance. And let's go. Yeah, so the number of nodes is correct, and the timing is around like the C version of WukongJS engine, which is very, very impressive for JavaScript. Very impressive. So let's go for a comparison now. Okay. Let's go for a comparison. So opening terminal and Node.js, UCI.js. By the way, I've added the perf feature into the UCI mode, so we can simply say position fen, then paste in the fen, and then say perf4 in our case. Yeah, this is slow as hell compared to, I forgot the guy's name, compared to Gontran's implementation. So let's have a look. Oh my god, it's still calculating, so slow. Yeah, the number of nodes is the same, but it takes 20 minutes. Well, it would be a bit faster without the video software recording. But yeah, this would be even faster without this video recording software as well. Yeah, my implementation truly sucks here. So the fact is real. So yeah, and now it's just want to try to reveal the reason behind this. I could have gone for some sort of a profiling to figure out, at very least, I don't know, some relative time taken relatively, like which routine takes the most time. In my case, this was the is-square attack. But okay, guys, I think it should be enough for this video, because we already have a working code to make a comparison with. So this work is very impressive, despite the fact that I hate the coding style. Well, it's not because it's bad, it's much better than my own, but I hate this because it's highly inappropriate for me, highly uncomfortable to work with. When I wanted to make a very simple thing, just trying to run this perf task in the way I used to do it, I really couldn't make this that easily. So I need to spend time diving into the implementation to figure out how in particular I can make what I actually want to. So yeah, but anyway, big thanks to Gontran Lemaire for, if you're watching this, and thank you for your code. So yeah, I think I now need to research, to make a little research on his source code to see why it's working so much faster compared to my, basically assuming exactly the same JavaScript language. Okay guys, so this is it from my side. Hope to see you in the next video. It's getting even more intriguing. So see you next time. Until then, and take care.